Alright, so now this is 6.5. This is the main bulk of the lesson. 6.4 was mainly just for some knowledge and some definitions, but this is where we're really going to focus on in the lesson for this time. But 6.5, talking about mid-segment of a triangle. Um, So the mid segment. So last time we learned about, in the last video, you learned about the median of a triangle. And the median meant that you drew, that it was a line that connected from the vertex to the midpoint of a triangle. So the vertex to the midpoint of the triangle. So these were medians. And then we learned about altitude, which was a line from the vertex and it intersected with the opposite line perpendicularly. Um, so those were those two. So now let's talk about the mid segment of a triangle. So the mid segment of a triangle is a segment. Another word for segment is line. Is a segment that connects the midpoints of two sides of the triangle. So there are three mid segments of a triangle. So it connects the midpoints of the two sides. So as you can see here, so here's a midpoint, and here's a midpoint, and here's a midpoint of the three sides of the triangle. So it's basically just lines that connect these midpoints right here. So these are called mid-segments because they connect the midpoints of the lines or the sides of a triangle. So there are three of them. Okay, so that is a mid segment. So we'll learn about this in just a bit, but so in this example, triangle JKL. So here is point J, as you can see. So point J, K, and L. Okay. So in the triangle, show that the mid segment MN. So here's a mid segment. So it's connecting the midpoint of this line and the midpoint of this line together. So it's just saying one of these mid segments. So show that this mid segment is parallel to JL, so that would be this line right here. So show that these lines right here are parallel, and also show that this line right here is half the distance of this line right here. So that's what we want to show. So first of all, so we want to show that they're parallel. Okay. Now, to show that lines are parallel, especially, so notice that this is on a coordinate plane. So these have slopes, right? There are slopes to these lines since it's in a coordinate plane. Now, if we want to show that these are parallel, then show the lines have same slope. Okay? So to show that these lines are parallel, we have to show that they have the same slope. Okay. Now I'm going to erase this definition, so if you want to write it down, make sure you pause it and write it down. But I'm going to erase it. So we want to show that these have that they have the same slope. Now to find the slope of a line, or to find the slope between 2 points, so first of all, let's identify what these points are. So M is the point 1, 2, 3, -4. So -4, comma 1, 2, 3. Okay, so that is the point M, and the point N is 0, comma 2. So now that we know their points, this will be helpful to us. So we want to find the slope between these points. Now to find the slope between these points, remember that slope is rise over run. Now to find the rise, we need to take y2 minus y1. And then to find the run, we want to do x2 minus x1. So again, so rise, which means the difference between the height of these 2 points. So that's why we do subtractions, because if you want to find the difference, you subtract 2 things. So we're finding the height between these 2 points, and then this right here means the width between these 2 points, so the run, right? So the rise and the run. Okay, so let's say that this is your first point, and let's say M is your second point. Okay, so that will help us, because then we could say that y2, so y2 means the y of your second point. So that would be this would be the y of your second point. So we'll say 3 minus now the y of your first point. This would be the y of your first point. So 3 minus 2 divided by the x of your second point. So that would be negative 4 minus the x of your first point, and the x of your first point is 0. So 0. So then this would be equal to 1 over negative 4. Okay, so that is the slope of m to n. Now let's find the slope of j and l. Okay, so the slope here is 1 over 4. Now to find the slope of the second of the other line, do the same thing. We want to find the rise over run, which would be y2 minus y1 divided by x2 minus x1. Now it doesn't matter which one you label as your first and second point, as long as you make sure you get these order correct. Okay, so let's label this one as our first point and this one as the second point here. So we want to do y2, so this would be our y2, which would be 1. So 1 minus y1. y1 would be negative 1. So minus negative 1 divided by x2. x2 would be the x of our second point, which is negative 6. And then minus the second point, the x coordinate of our first point, which would be 2. So if you do the math here, 1 minus negative 1 is actually 2, and negative 6 minus 2 is negative 8. So if you reduce that fraction or simplify that fraction, you get negative 1 over 4. So you see here that they have the same slope. Hence, we can say that the lines MN is parallel to JL. There you go. So these lines are parallel. Okay, so now the second thing is to show that this line right here is half of that line. So we need to know the distance. So here is what you can use for the distance. So the distance between 2 points on a coordinate plane is equal to, so d is equal to, d for distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so again, you need to make sure that you identify which point is which. So if we want to find the distance, let's say we find the distance for m and n, so I'm going to call this one 1 and this one 2. So for mn, the distance is the square root of x2, so that'd be this one right here, so negative 4 minus x1, so negative 4, and then minus x1 in this case would be 0. 1 second. So we have negative 4 minus 0 squared plus, and then y2, which would be, so y2, which would be 3 minus y1, and y1 would be 2 and squared, so that would be equal to the square root of that'd be negative 4 squared plus 1 squared. Okay, so if we do that, that's equal to square root of 16 plus 1, so that's equal to the square root of 17. So let's leave it like that. Now let's find the distance from JL. So I'm going to label this one as my first point, this one as my second point. So we do the square root of x2, so that would be negative 6 minus x1, which would be 2 and square, and then plus, so y2, which would be 1, minus y1, which would be negative 1, and that's squared. So that'd be equal to the square root of, so negative 6 minus 2, that would be negative 8. So negative 8 squared plus 1 minus negative 1, which would be 2 squared. So that would be equal to the square root of 64 plus 4, and that would be equal to the square root of 68. Okay, now obviously those don't look like the same, or double or half or something, but the square root of 68 is actually equivalent to, well, if we divide it by 17, so 1 second, let me go to my calculator. So 68 divided by 17 is equal to 4. So then I could rewrite this as the square root of 4 times 17, and then that would be equal to the square root of 4 times the square root of 17, and that's equal to 2 times the square root of 17. So look at this that we have here. Here's 2 times the square root of 17. That is the length of JL, and the length of MN was 17. So obviously you can see that this line is 2 times the length. It's double the length of MN. So therefore we can conclude that MN is equal to half the size of JL. So there you go. Now this leads us directly to the triangle mid-segment theorem. Now the mid-segment theorem states that if DE, so if DE, 1 second, so if DE is the mid-segment of this triangle, so again we need to make sure that we have requirements. So 1, DE is mid-segment, of the triangle. So in this case, we'll call this triangle ABC. So if it's the mid-segment, then there are actually two things that this means. This means that DE is parallel with this side over here, so AC, and this also means that DE is equal to half the size of AC. So that's the triangle mid-segments theorem. Okay, so let's try and use this mid-segment theorem. So here it says that triangles are used for strengthened in roof trusses. In the diagram, UV, so this line right here, UV and VW are midsegments of triangle RST. So these are two midsegments of this triangle. Okay? We want to find the value of UV, so we want to know the length of this truss right here and the length of RS. So that'd be this one right here. And notice what it gives you. So we are given that RT is equal to 90 inches. And we know that VW is equal to 57 inches. So now we want to find the length that we just said before. So first of all, since UV is midsegment of the triangle, that means it is half the distance of this line right here. So I know that UV is equal to half of RT. UV is equal to half of RT, and I know that RT is equal to 90 inches. So then UV has to be equal to 45 inches. And I know that from the midsegment theorem. Okay? Now, I know also that VW is equal to half the length of SR. And I know that VW is equal to 57. So I know 57 is equal to 1/2 SR. So if I want to find the length of SR, or RS, I guess I should say RS, because that's what the book is asking for, so RS. Then I multiply by 2, so then RS will have to be equal to 114 inches. Alright, there you go. Let's do one more problem here. So in the kaleidoscope image, AE, I'll try and find a color that might be used, AE, so right here, that doesn't help. So AE, and BE, so AE and BE, so these lines right here are, sorry, not that one. So these lines right here are congruent, okay? So yeah, this line right here and this segment right here are equal to each other. AD and CD are equal to each other, and we want to show that CB, so this right here, CB and DE are parallel. So first of all, since we know that this is a midsegment right here, or sorry, we know that this, and it's really hard to see with that, I'm sorry about that, but CD and AD are equal, so that means, and this are equal, that means that this is, that DE is actually a midsegment, right? It has to be that it is a midsegment, and that follows from the theorem, right? The theorem, the definition of midsegment, that is, follows from the definition, because this would have to be a midpoint and this would have to be a midpoint. So that means this line connecting them is a mid-segment, okay? And because it's a mid-segment, then it follows from the theorem that CB is parallel with DE, okay? So first of all, we know that D and E are midpoints, and that's by definition of a midpoint. Then we know that DE is a midsegment, also by definition. And so, since it is a mid-segment, then DE has to be parallel with CB, and that's from the mid-segment theorem. Okay. So yeah, that's really all you had to show. Really not too bad. But that should pretty much do it for the rest of this lesson, the triangle mid-segment theorem.